Okay, we have some chapter review problems, and I want to remind you that this does not indicate that this is a full, complete review, but meant to be a review of some of the main concepts of the chapter. It says here that -1 minus 3i is a 0. Well, since p of x has real coefficients, that's one of the requirements. Therefore, -1 plus 3i is also a 0. Now, there are a couple ways of finding the third 0. One way, and not the way I recommend, is for you to say x minus this -1 minus 3i times x minus the -1 plus 3i times question mark is equal to p of x. This is not the best method because you've got to do all this distribution and then divide this out of p of x to see what the remaining factor is. Since two of our zeros are imaginary and there's only one more zero because it's a third degree function, that last one must be positive, or a real, I should say. So let's try just using our rational zero theorem to try different values until we find one that works. Here we go with 1, 3, 12, and 10. Now the first thing I would check is 1, but notice something. All of these terms are positive. And by Descartes' rule of signs, when there are no sign changes, that means there's no positive real zeros. So 1 is not going to work. So I'd move on to -1. Bring down our 1. -1 times 1 is -1, plus that 3 makes 2. -1 times 2 is -2, plus that 12 makes 10. Then we have -10 plus 10, which is 0. That tells us that -1 is a 0, and that our zeros of this function are the -1 we just found, and -1 plus or minus 3i. We are asked to sketch this graph, and it's already in factored form for us. We can see that the zeros will be -1, 2, and 4. So I can go straight to my graph and plot those zeros, -1, 2, and 4. If we were to multiply all of this out, there would be an x squared in the first parentheses times another x, and so this would be an x to the 4th function with a positive leading coefficient, which tells us that this graph is going to have a W sort of shape, with both ends pointing upward because it's an even degree function with a positive leading coefficient. Now, -1 has an even multiplicity, and because of that it tells us the graph is just going to touch the axis there, whereas opposed to the other two x-intercepts, they will cut through the axis. So I'm going to draw a quick sketch of the graph. It's going to go up at the far left, come around and turn around and go back up. Turns out that if we stick 0 into the function, we get 1 times -2 times -4. We get 8, so our graph is going to intersect right up there somewhere. So it's going to be very steep up. I don't know how high it's going to go up, whether it's come down, who knows. It's going to come down, cross through, go down a ways. How far, I don't know. We'd have to substitute some values in. It could go way down. But that'll be the general shape of our graph. Now this next problem asks us, with the same function, where is this less than or equal to 0? And we can see the equal to part right here at -1, and we can see between 2 and 4 it dips below there also. So our solution set will be -1 united with the closed interval from 2 to 4. And I say closed interval because I'm including both endpoints because of that equality with 0.